Okay, so we are recording now. Let's start. I just want to put like a quick abstract, okay? Why are we assessing this important topic? Because I'm sure that most of you know that like most of the telcos, most of the service providers, most of the CSPs, communication service provider, mobile operators, are all undergoing or all witnessing now like a full digital transformation initiative. They really want to transform the way they provide service to their customers. They don't want to be in a competition with mobile operators or CSPs. They want to compete with the DSPs like digital service providers like Google, like Amazon, AWS. And you will always find that AI is the main brick of these kind of programs. But the problem or the complexity of assessing this topic that it is actually you always find it there as a scattered initiatives that you find AI in many domains like in the network and the IT and the OSS and the BSS and the billing in the sales in the marketing the products. So you always find it as scattered initiatives. You don't see like some sort of a solid reference architecture or a solid ecosystem. And also you'll find a lot of buzzwords, like the same problem with the cloud. So I'll try in like the next 50 minutes to just open the door for understanding the concepts or the AI or ML in the telco space. I'll try to shed some light about the use cases, how it is being embraced currently in the telco space. And also I will try also to show the convergence with other technologies which are like closely coupled like cloud native. So I made the next slide just to set the stage for the webinar today, just to give you an overview about the positioning of the AI with respect to the telco domains. So digital transformation usually is a program, okay, is an end-to-end initiative that runs across all the organization borders, and telcos are not an exception. So in telco, there are multiple domains. There are the resources domain, like the infrastructure, the cloud, the passive stuff. There is a service domain where you find the like the actual service, like the core, the radio, provisioning tools, OSS systems. And there's the customer domain where you find systems like the customer order management and customer troubleshooting and customer service handling, CSR toolbox, this kind of BSS stuff, and these tools of these systems of customer facing, for example, problem management. And then you have the product management. That's where telcos define the product, make the product life cycle management, and the market sales domain. That's where the telcos expose their portfolio across digital channels, across marketplaces, even the shops, these kind of things. So most probably, if you are working in the telco space, then you are working more or less in one of these domains. So to realize digital transformation, there are a lot of initiatives that converge together to realize that kind of target of a digital transformation of a CSP. So for instance, in a product domain, operator thinks to try to provide new digital offerings. For instance, not just providing internet connectivity and voice and SMS and this kind of legacy stuff, but also try to offer digital offerings. Try to do things like AWS is doing, for instance. Providing innovative stuff like SD-WAN plus subscription to a certain software, SaaS. So that's the new digital offering thing. In service resources domain, you find that the deployment of cloud native and stacks and cloud is actually part of digital transformation. You cannot achieve digital transformation without having the right infrastructure. And there are a lot of other initiatives that spans across multiple domains like automation, orchestration. In the sales, you evolve your digital channels, so you start to have a nice application, digital app that exposes your service and eat the interaction with users. For the whole domain, you start to modernize the operational model, you deploy DevOps, you enhance the digital user experience, and also you find that AI, ML, artificial intelligence, machine learning is a main brick of digital transformation. And most of the operators, they are assessing this kind of thing. They are deploying AI, ML in different layers. You find AI or machine learning stuff as a preventive maintenance in the resources domain, service domain. In the customer domain, you find the use, I'm just mentioning example, the use of chatbots. So it is there in customer domain. In product, for positioning the right product that suit the customer requirement, this kind of recommendation systems is based on AI ML, and same case apply for the sales and sales channels and digital channels. So AI ML spans across all domains of telco borders. You'll find that in this session, we will always focus on the service and resources domain because that's where the telco and the network guys are working on, and that's where I'm focusing. I try to search for a basic classification that I can use to build the content on, and there are a lot of classifications online, a lot of things. So I like this one because it's very basic and it's based on the capabilities. So from capabilities perspective, it is commonly, known or agreed that there are three classifications. We have the narrow AI, sometimes labeled as weak AI, and there's the general AI, sometimes labeled as strong AI, and there's the super AI. The narrow AI, actually, these are like the systems that is very trained to do a specific task or address a specific problem in a limited domain. And there are some examples that I put here, like Siri, like image recognition, recommendation systems. But if you want to map that to telco systems, something like a preventive maintenance system that is there in the cloud, or that is there on the radio, or that is there in the core. So this is an example of the narrow AI, because it's a very task-oriented, solve a specific issue in the telco subdomain, and usually it cannot span across multiple domains. So it is made for that radio, for the core, for the network, for the transport. So most probably whatever we are going to talk about in this webinar, or in general in telco, belongs to the narrow AI. The machine learning, itself, the term that we are going to use, belongs to the narrow AI. General AI, or the strong AI, that's something that should have the ability to learn and apply this kind of learning knowledge to a wide range of domains and wide range of tasks. So it actually very compared, or the target is to be compared to the human intelligence and the cognitive capability of the human, so that it can reason, it can learn, it can adapt, and that's something that's not used even in the telco, and even widely is not there. It is one of these things that under development and under research. Super AI, it's a very hypothetical stuff that actually an artificial intelligence engine or a solution can even surpass the human intelligence. So the cornerstone here is that whatever we are going to talk in this webinar, whatever techniques that we're going to address in the telco space, belongs to the narrow AI. Then, towards an AI native telco network, a network that's AI native by nature, that is designed to be AI native by nature, we had just to interpret how did we start, the current state, and where are we going. So I chose like an initial step where the AI or the ML capability started to appear as a local product capability. For instance, some products from some vendors at a certain stage, they start to develop some sort of machine learning capability. For instance, instead of taking a decision based on inputs or based on clear equations, it actually takes decision based on a machine learning algorithm. And I chose the feature that was there in 4G, which called smart paging in the MME, the 4G core entity. So usually in back to 2008, whenever there is a connection or a request or data is coming to a certain user, and that user is idle, Usually, the MME or the core node of the mobile network used to do paging, broadcast paging for this user. So it calls his name into what we call a tracking area, which is a large geographical area. But with smart paging using the machine learning, it actually predicts that that user could be at these cells. So it does the paging on the cell level or the on the E node B level. So this kind of feature was seen as one of the first steps to adopt machine learning techniques as part of telco use cases. So smart paging was there, and it's just an example that you may have the machine learning as a local capability of one of the products, and in that case, it was the MME. The other step is that you can have the machine learning capability or the AI capability as a product, exposing this capability to other products or to other network elements. Or you can see this capability as a platform as a service or software as a service exposed to the other networks. And I chose here, first of all, you can always look for the red block. So red block, in my definition, that's the ML engine. So that kind of logic, I brought an example from the ORAN architecture. So there are our apps or the non-real-time RIC applications. These are the applications that actually use the data to trigger actions related to radio optimization, this kind of things. So we start to see this trend to have this kind of capabilities part of the architecture, and that was brought by ORAN. But a very, very solid example of this kind of product capability exposed to other capabilities, what we see in the 5G. So in the 5G, there is that element, the NWDAF, the network data analytics function. This is function that actually provide data analytics service to all other 5G nodes. And we started, for instance, to see something like AWS offering this node as a SaaS, as software as a service. So whenever you deploy a 5G core, you can use this service from AWS. So this is one of the current states that we are in. One fashion also of having the ML capabilities on the network, and also we see that in the telco space, is actually having this capability as an extension of the OSS systems or of any centralized management systems. For instance, if you have some sort of orchestration tool or end-to-end automation tool, you find that the roadmap of such a solution, such a product, is to have a policy engine, is to have a machine learning engine. And you can see that clearly, for instance, when you see the own app architecture, you see that, and the own app, that's the framework for the automation and orchestration that was actually originated from the ecom project from AT&T. You see that inside the orchestration, there is explicit products that like policy engine, and that provide this kind of machine learning capabilities. And now, if you examine any kind of orchestration solution coming from the big vendors, Nokia, Ericsson, Netcracker, Blue Planet, you'll always find a policy engine that's actually providing machine learning capabilities to the other nodes. So these are actually the current states that we are in. What we are looking to achieve, and hopefully this also we have big expectation of that coming with 6G, is to have an architecture that is AI native by nature, an architecture, a reference architecture that actually shows the exact positioning and the exact interlocks with an overlay machine learning solution. And this is one of the issues or the obstacles of adopting machine learning currently, because usually telcos, they build their architecture, they build even the team's enterprise architecture based on reference architecture, based on standard reference architecture. And because of the fact that machine learning was not embraced by an SDO to formulate an end-to-end architecture positioning AI like AI data sources, machine learning orchestrators, machine learning training model, how to handle these kind of things. This is what actually caused the delay in the adoption. So what we are looking for is actually to have a standard reference architecture from SDOs to mandate, like what 5G did when 5G came and mandated in WDAV. You find now a lot of telco people talking about, okay, let's bring this data analytics, let's do machine learning. This is what happened also in the O-RAN when they brought the non-real-time RIC and it had the machine learning capabilities. Most of the radio callers started to say, yes, we need these machine learning technologies. So having a reference architecture is mandatory, or it is important to enable telcos to achieve or to get to that stage. Another advanced step is not just to be AI native by architecture, to be AI native by design. The way you engineer your microservice, the way you engineer the CNFs or the application should be AI native by nature. And what does this mean? The way the microservice react to operations like lifecycle management, the way they do the healing, the way they do any kind of upgrade process, the way they are monitored by monitoring systems, all these should be built centric on machine learning techniques. So that's actually not there. That's not there. And we expect that the next generations of applications, it will be like that. So in engineering or in structuring the application itself, it will take into consideration the dependency on machine learning techniques. For instance, if there was certain logic to do healing based on a certain observation, then we can assume that healing will be made, self-healing will be made on prediction using a machine learning technique. So this is just the journey, how we started and the current state, and what are our expectations that we are going to achieve. Next part will be the convergence with the cloud, how cloud is contributing to that domain. I can stop here and take a few questions. If not, I can continue. Okay, so there is one question about what about generative AI in telco, and for sure that's a very trending topic. So generative AI, the AI solutions or capabilities to produce content based on certain inputs, it is still considered as a narrow AI. It's still a narrow AI, so it is in same category of what telcos are using. However, there are no still concrete use cases at using generative AI, because the whole hype is about the solution that are actually integrated part of overall architectures. And like, for instance, like when I say O-RAN, so you deploy the machine learning techniques to fit to the O-RAN. When you are doing like a cloud stack or a cloud deployment, then you are interested in the preventive maintenance on how you support your service. So these are the current focus domains of AI. However, what we see on the MOUs signed between operators, for instance, and Microsoft, ChatGPT, and this OpenAI. So I expect in the next 2 years, you'll find a list of use cases that may use generative AI and even advanced techniques. There's a question, and then I will go to the next section. How a non-ML based environment progress for self-healing based on AI in absence of automation? So automation is a main brick, Ahmed. Automation is a main brick. Even you'll find most of the end-to-end solutions are actually about a policy decision engine, ML based, that take a decision And then anything after that and before that even is all about automation. So self-healing in the old days, it was done by some as a local capabilities of some products. For instance, a certain VM monitors the other VMs, and when it detects that there is no keep alive, it triggers a certain action to the infrastructure to restart the VM. So it was all a local capability. But using the ML framework, it will be based on a certain machine learning model trained to predict a status of a certain microservice based on certain inputs or certain conditions. And this kind of system is closely coupled with an automation system that actually triggers or execute the self-healing. Now let's see the image, the cloud. So cloud classically with starting from 2013, 14, in the telco part, not in the IT part, it was all about infrastructure as a service. It was all about like a private cloud deployment based on a specific cloud infrastructure, providing certain infrastructure as a service, only giving virtual machines to the internal customers, which were the telco VNFs. And together with that stack, there were some controllers like OpenStack, like SDNs. There were some attempts to do some automation stuff, either using commercial orchestrator, using tools like Ansible. And for sure, all these were covered by FCAPS tools, providing fault management, configuration, accounting, performance, and security. So that was the classic stack for the Telco cloud stack, and it was all originated from Etienne V reference architecture. What we see currently, and I'm more focused into the private cloud, but nothing stop us even for expanding this example to public cloud. But I'm talking about the private clouds. What we see currently is that the cloud offerings, the telco cloud offerings, has now expanded from infrastructure as a service into CaaS and PaaS. So currently, most of the telco operators, they have CaaS platforms like Kubernetes-like platforms that actually provide the right environment to host the new cloud native network functions or applications, like for instance, the 5G core, which is containerized by nature. And we also find that there is also an evolution on the PaaS level, on the platform as a service. You may also call it software as a service if you are talking about a public cloud offering. So part of the platform as a service offering is actually the data analytics. So most of the offerings coming from cloud providers, just name any cloud provider that you know, like Red Hat, AWS, Google, any cloud provider. Okay, you'll always find that there's a solution that actually does the data analytics, that acts as a machine learning engine or a data relying on a data store. Also, the FCAPS, the way we do the fault management and performance management, all the stacks now are providing a sense of a closed loop control. Closed loop control that you monitor the environment, you detect a certain outcome or a certain output that triggers a programmed action to expand, to heal, to do whatever. So that's a closed loop control. Now it's being advanced to be AI based, like to do a sense of a preventive maintenance, not to wait to have the output or the outcome from the environment, but to predict that a certain action will happen. So you take a preventive action. So this is an evolution that actually we are seeing now from cloud offering perspective. From a hardware perspective, we see also a huge evolution in the hardware capability that will enable us to do machine learning modeling, machine learning testing, validation, and certification. So there are a lot of specialized hardware that are evolving, like GPUs, TPUs, these kind of things are and accelerators are there for sure. So now cloud is adapting to the need to run machine learning based solutions on the telco environment. Together with that, we have now, and that's became like a solid ask from all the operators, to have some sort of an engine, external engine, data analytics and policy engine as part of the offering. So most of the data coming from that stack, from infrastructure level, from cloud level, from service level, are all fed to a certain data lake or data store that actually eventually goes for data analytics. So this is now became like a solid part of any cloud offering. So you see, that was a journey that started in telco, again, in telco domain, not in the IT, starting from 2015. And now we are 2023, so 8 years of progress. And I think it is still going on, especially with most of the telcos now embracing the hybrid cloud and embracing having both private and public clouds. I can stop here and maybe take one question about the cloud part. Okay, there is a very nice question that I'm going to say repeat now and then discuss it, because it reflects actually the way telcos, I would say, think of cloud workloads, and how AI ML solve this kind of puzzle. So the question is, restarting a VM via AI machine learning, don't you think it is a compliance to customer without any change request? So the question is all about how can you take a decision to heal or to restart the VM via ML engine without having a change request, without taking the customer's approval. So this way of thinking, it is there, and it was there at the beginning of the cloud stacks in 2015, where you used to treat the VMs as your pet. So you are keen about the VM. No, nobody healed the VM before asking me. Nobody restarted the VM for asking me. But the evolution of the application itself, being cloud native, now the VM is not even talking about containers. Now the container or the pod is not important anymore. It's not important in the sense that it is thought to be stateless. So if you kill a container or a pod, another pod will rise up, and he will be able to fetch the data from database, because database in the backend. So the way you engineer now or engineer the applications based on microservices has now made it easy to use techniques like automation and machine learning to take actions that were hard to take without approvals. So you cannot just restart a VM in the old days, because this will definitely will impact the service, and then you will get a lot of escalations. But now if your application or CNS is based on containers or based on pods, then all these nice techniques and modern techniques will apply. Because again, the container itself or the pod itself, this is not the important part. The important part is the service. And with these kind of techniques, we guarantee the service will be continuous and will not be interrupted. So now I take you to a very important topic, which is actually the MLOps. And because whoever wants to deploy machine learning based solutions at a certain environment, then implicitly or even explicitly considering the MLOps. So what is actually the MLOps? Let me read the definition, and I gathered this definition from many sources. Like I took part of from Red Hat definition, and also added part even from ChatGPT. But I tried to put some nice keywords that we are going to assess in the next slide. So let me just read it. Machine learning, or MLOps, is defined as a set of practices, organizational processes, and technical capabilities to enact the full operational lifecycle of a machine learning model in an application. That's very close to the DevOps definition. So it seems that to manage the lifecycle management or operational cycle management of a machine learning model, you have to deal with that model as an application. And whenever it is an application, it is a software, then all the software practices apply. Then the DevOps techniques, the CI/CD, the pipelines, all these techniques apply. So it looks here that whatever we are going to do is actually we need to deal with that machine learning model, this kind of algorithm, as a software, as an application. So the second part of the definition, it combines the principles of DevOps with machine learning workflows to ensure efficient and reliable operationalization of machine learning systems. Okay, that makes sense. So it looks like that we will capitalize on the DevOps workflows, the one that is we have a good experience about it. Most of us, people, colleagues in the IT, colleagues working software development and the cloud. So we are using these kind of principles to make sure that we have an operational workflows of machine learning models. So let me explain that. I prepared like a storyboard, a basic one. I will not go into details, but just to give you the look and feel on the overview of a machine learning model and what is actually MLOps. So let's start. And let's start with something like you have an issue, that you have a certain problem. You found that, for instance, you have some sort of operational KPIs is going down. The time to fix, the time to repair, the service uptime, any kind of operational KPIs that created a need, for instance, to bring preventive maintenance. That, okay, you get a task from the management, you get a task like after discussion with your peers that we need a machine learning based solution to enforce preventive maintenance, to avoid the service interruption, to bring more user like happy customers to us in the front. So basically you start to think, okay, then now I need some sort of algorithm, or I need some sort of a mathematical representation of this problem of the preventive maintenance in the field, for instance, for radio network or core network, to make predictions and assess the data and make prediction that we should do this or do that. So the first thing that you need to do is actually the machine learning model development, which is basically the selection of the machine learning model. So what kind of machine learning model that you're going to use to solve this problem. So in that part, in that stage, you start to experiment multiple models that are there. There are many models that are actually well known in the community. So you start to experiment these models. What model shall I use? Okay, what model that will help me to make the perfect predictions to make me achieve my KPIs? But to actually experiment a machine learning model, actually eventually to train a machine learning model, what do you need? You need data, right? So the second thing that you may think of, okay, then I need the data. And data, I just highlighted that in two things, data source and data feed, because data source may vary. Data source may come from EMSs, may come from various monitoring systems, logging systems that are there in different domains, like in cloud, in hardware, infrastructure, in the core, in the radio, in the service, everything. These are all data sources. So these data sources are usually fed to a certain data lake or data warehouse or whatever. But at that stage of data feed, before you feed that to the machine learning model, you need to do some stuff. You need to do, for sure, you did the collection. Maybe you can do some data cleaning, to remove the duplications, for instance. You can do some labeling, and labeling like putting some labels that will aid the machine learning model in classification. So this is actually what is about data feed. That's to feed clean data to the machine learning model. And then you have the machine learning model, you have the data. You need to train the machine learning model before putting this machine learning model into production and having this machine learning model into action. You need to train the model. There are several training techniques, right? Like supervised and not. So you can, like reinforcement learning. So a lot of things, a lot of techniques to be made in model training. But eventually, from engineering perspective, that you have the machine learning model, you have the data. So you need to do training or model training. So in that part, you build the machine learning model. You start to train the model, and you do something what we call the evaluation or validation. Like there are some KPIs or some metrics that for instance you make the machine learning model predict values, and then you compare these values to the one that actually happened, and then you for example inspect some standard errors between them until you reach a certain threshold or KPI acceptable to say that model is validated. And once this model is validated, and it may also pass about some kind of policy validation. For instance, if that model inspects the facial aspects or inspects the identity of people, so maybe this violate a certain rule of preventing this kind of AI-based solutions to bring the identity of people. So that kind of part, you do the model validation and compliance to policies. And once it is ready, you deploy the model into production. And this is a very high level way of thinking, like how to think or how to deploy a machine learning model to bring value to your environment. So you had the problem, you searched for the right algorithm, right model to represent this problem. You get the right data feed, you did the cleanup, you did everything, and then you fed that data to machine learning model, and then you start to train the model. And once it reaches a certain maturity, passing certain threshold, reaching certain KPIs, you deploy the model. But in reality, it is more complicated than that. Not the best animation, but anyway, it's more complex than that, because there are a lot of feedback loops. For instance, the model itself is a code, right? It's a source code. It's pushed into Git. So, and that Git-based pipelines very similar to what we do in DevOps. So that's the intersection between both and the conversion between both. And that code, eventually, to deploy a code, you have to package that code in a deployable unit. And that's sometimes people call it source to image. So in the model serving pipeline, you convert the code into a container image, and then you apply this image as an application. So this model will serve as an application, as a containerized application. And that's 100% fits the DevOps and the CI/CD workflows. And that's again the convergence between the machine learning and the DevOps, and that's the MLOps. For sure, it is more complicated, and there are a lot of processes. I will share the slides, and I put a very nice link from one of the Red Hat documentation, like 2 years back. It's one of the blogs, but it will be very sufficient to help you show, to help you understand the full cycle of the MLOps. And just to tell you that many now consultancies are offering this kind of service to help the operators or the mobile operators, telco operators, how to deploy and maintain a successful MLOps framework at your organization. So I hope I covered it in a I would say in a systematic way. I'm sure now, when you start reading about MLOps, things will be clear for you. I will stop here and get a question, and then I will show you one of the examples of AI native by architecture, and that's the ORAN, how the ORAN is actually trying to be AI native by architecture. Okay, so there was one question about the last section about incidents of pod restarts. Are these logged and reported for customer? Yes, they are logged and reported for customer, but usually you shouldn't worry a lot on the pod level. You should worry about the service level, because cloud should do the needful to make the service up. So we shouldn't worry about a pod being restarted. We should worry about the service. Any questions about the machine learning operations, MLOps? Okay, so this is the ORAN architecture, the high-level architecture, the one that is there in the standard documentation of the ORAN Alliance. And the O Cloud, that's the open cloud hosting, the RU, read unit, and distributed unit. And there is a centralized unit, CU, CP, control plane, user plane. These are like the radio part. And then on top of this radio part, there are two intelligent controllers or two orchestration layers, which is the near real-time RIC, radio intelligent controller, and the non-real-time RIC, or the non-real-time radio intelligence controller. If you go through the internal structure or internal architecture of the non-real-time RIC, which is actually what we call as SMO, Service Management and Orchestration Framework. One of the duties of that layer is actually to do the AI ML workflow discovery. They are talking explicitly about the machine learning model training, and they are really lucky, not lucky, but radio, actually, that umbrella is the one who collects the most important and the most robust information from the radio unit. So if you see here, all the radio units like ODU and B, they are all exposing this kind of metrics and logs and data to the RIC, which is go to the non-real-time RIC through the A1. So all this data from the radio that we used before to do actions about optimization are fed into the non-real-time RIC, and that's why one of the non-real-time RIC functions is to do the model trainings and provide these updates to the R apps. And the R apps are the system or the application that take decisions about radio optimization, radio capacity planning, and radio whatever. So they make this machine learning model as a service for these R apps to take decisions as part of the radio domain, like capacity, like planning, like optimization, enhancement, congestion avoidance, these kind of things. So what was interesting here, that because of that architecture, that encouraged many of the operators to explicitly ask for these capabilities at their RFP or at their request for quotation for the ORAN. And that is what I told you about, that standard architectures encourage and helps operators to adopt technology. So ORAN is a good example of an architecture that is actually brought to be AI native by nature. And as I said, I do have expectation and hope, and that is what I'm following, that 6G will bring the same to the overall network architecture or mobile network architecture. My last slide is actually a discussion. Okay, how to reach an AI native network? What is the contribution from us individuals, from entities, from vendors, from operators? So my first point, and that's very important, that it's not only about technology. Machine learning is not about technology. This actually should be part of a transformation blueprint. Like operators need to understand how this machine learning technology or solution should contribute to the overall transformation. And we, as an vendor suppliers, we should also provide this kind of transformation blueprints. Because what happened on the cloud that telcos introduced cloud stacks without changing the operational model. So they got stuck with technology, like they say, like you put the carriage in front of the horse. They brought a nice technology, but operational model and processes stopped the flourish of these kind of technologies. Second thing, standard architectures. You have to embrace, you have to define a standard architecture that actually shows explicitly the existence of this solution. And I really greet and the effort done by the ITU on that part. They have a really nice documentation about a machine learning overlay solution architecture that you understand exactly how you deploy a full machine learning solution overlay on top of your network, which is the underlay in that case. So we need something like that from 3GPP and in 6G. Third point, it's a smart move that many vendors used to do, is actually to make sure that he has a success story to replicate to other operators. So he can go, for example, to an MVNO or to a small operator with a small, like I don't want to say a small country, but maybe small number of users, and then try this new technology and give this new technology for free, and then have a successful model, and then you try to replicate. One of the things that stops the adoption is the unclarity about the technology and the lack of references, because you go and you try to sell a solution, try to sell an idea, but the question is, did it work somewhere? No, then people will be reluctant. The fourth point, and it is important for me, that you have to avoid the technology fragmentation. You cannot have 5 references or 8 references. You have to confine the work. You have to collaborate together to have standard document or 1 or 2. But when you have the same technology addressed and exposed in multiple SDOs, you see the same talks in GSMA, you see in ITSI, in 3GPP, open source groups, Linux Foundation, ORAN, ONAP, a lot of things, a lot of initiatives. This kind of fragmentation that's happening slower the pace of the technology adoption. And we saw that big time in the cloud. And we saw that big times even in the part when we started to adopt the containers and the container platforms. So there should be some sort of standardization confinement. And that leads us to the last point. We need to have collaboration between all operators, all vendors, to show successful POCs and show successful pilots. And this is something good that the ORAN did. They did a lot of POCs, a lot of pilots. For some reason, the pace was not that high, but nowadays we see many productions or commercials deployments are coming because of the efforts done on the pilots and the POC race. So this is actually the 5 key pillars that we have to work on to make sure that we are walking, or we're going into the right track towards AI native networks. With that slide, I reach the end of the webinar. Thanks a lot for your attendance. We have 5 minutes, so we have space for questions and answers for 5 minutes if there are any. There's a question about the recorded session. It will be on YouTube. The document, asking about the document. Yes, the document, I'll share the document on LinkedIn. Do you see any regrouping or a common ITSI and ORAN architecture in the future? Yes. Yes. I see it coming, because many of them, I see that realize that they need to converge. And then there's a big question about what are best practices and key considerations for implementing MLOps in an organization to ensure efficient and scalable deployment of machine learning models. So the question is actually to implement MLOps in an organization, scalable, efficient, what are the best practices? So my main message is to deal with this kind of initiatives as a cross-organizational initiative, not to be taken by one team and then try to look for useless integrations, try to contact with east-west with other teams. It must be an initiative cross-organizational. I see, because of the complexity of telco organizations, you cannot avoid having a horizontal task force team. Like you will have an MLOps task force team across all departments. You start first with some enablement, few months, enablement workshops, enablement sessions. What is MLOps? What is actually the key strategic thing that we want to achieve by MLOps? You get, for sure, you get the buy-in from the executives, from a main sponsor, and then you do the enablement, you do assessment, discovery, discuss the as is, set the to-be state, identify the gaps, procure the product. So there is a process that you should work on to reach eventually an efficient and scalable MLOps, and that applies for DevOps. But again, the third thing, the sponsorship from executives, from the CTO, linking that kind of initiative to a strategic KPI outcome, starting with enablement, forming a horizontal team, task force team, doing discovery, identifying gaps, enforcing culture, and procuring products. And then you need some sort of consultancy from the right entity for some time, and then those people will go back to the back seats, and then the operator team or the task force team will lead. This task force either eventually move to be an entity that actually takes care of the machine learning stuff on the organization, or they actually continue to work as a virtual team across multiple departments. I hope I was clear on that. It's a very interesting topic, but unfortunately short time. We only have 1 minute. Thanks a lot. Yes, Noor, you're right. MLOps require a complete transformation for the whole stack. Yes, you're right. Thanks, Hassan. TTLP, Panjoko, thank you. Omar, thank you. Sherwat, thank you. Thanks a lot. Thanks a lot. It means a lot to me that actually you come here. I know it's a weekend. I'm sorry for that, and maybe not the best time zone, but yeah, thanks a lot. Thank you. See you. I will just copy all the questions and try to answer that offline for the question that were not answered during the session. I will now stop the recording, and thank you again.